Topic 8, Subtopic 8.1, Events and Probability, Learning Outcomes. At the end of this lesson, students should be able to find conditional probabilities and independent events. Conditional events: when an event happens, is considered with the condition that another event has occurred, then the event is a conditional event. Conditional probability is the probability that an event will occur given that another event has already occurred. For examples, the event that a girl is chosen knowing that the student wears spectacles. 2 balls are taken from a box containing several red and blue balls without replacement. The event that getting the second ball depends on the first ball. Keyword: knowing that, given that. Okay, this is the formula for the conditional probability of A given B. This one right here is read as the probability of A given B. So this is the formula for the probability of B given A. If it is stated that A and B are mutually exclusive events, then the probability of A given B, the probability of B given A, and the probability of A intercept B are equal to 0. This one right here is an example of a tree diagram for conditional probability. Note, to find the probabilities, you must multiply along the branches, okay, and add between branches. Example 16, A and B are 2 events such that the probability of A equals 1/3, the probability of B equals 1/4, and the probability of A union B equals 1/2. A, find the probability of A intercept B. So let's just use the formula. And substitute the values, you get 1/12. Question B, the probability of A intercept complement of B. Okay, let's refer to the contingency table in page 8. You can see here that the probability of A intercept B plus the probability of A intercept complement of B equals the probability of A. Let's write that down. So P, A intercept B plus B, A intercept complement of B equals PA. And then we can rearrange this to get P, A intercept complement of B equals PA minus PA intercept B. We can use this formula for question B. Okay, let's write down the formula. Okay, substitute the values. And then you get 1/4. Question C, the probability of B given A, using the formula given in page 14. The probability of B intercept A is equal to the probability of A intercept B. That's just the same thing. So substitute the values, simplify, and you get 1/4. Question D, the probability of A given B complement. So again, use the formula in page 14. Substitute in the values, 1/4 over, okay, the complement of B is 1 minus 1/4. Simplify that and you get 1/3. a card is chosen at random from a set of 25 cards numbered from 1 to 25. What is the probability that the card chosen is a multiple of 4 given that it is greater than 50? So let A be the event of choosing a multiple of 4. 4, 8, 12, 16, 20, 24. And let B be the event of getting a number greater than 15. So 16, 17, up until 25. The question is asking for the probability of A given B. So we need to find P A intercept B and P B. So for the probability of A intercept B, we have 1, 2, 3. So 3 over the total number of cards, 25. And then the probability of B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 over 25. So the probability of A given B equals 3 over 25 divided by 10 over 25. Simplify that and you get 3 over 10. Example 18. 30 mathematics professors out of 100 who are examined were found to be overweight. 10 of them had high blood pressure. Only 4 of the professors who were not overweight had high blood pressure. Find the probability that a mathematics professor will not have high blood pressure if he is not overweight. So let's draw a table for this question. So let H be high blood pressure and W is overweight. W complement, H complement. This is for total. And so we have a grand total of 100 professors, total of 30 overweight. What else? 10 of them, 10 of the professors who are overweight had high blood pressure. So 10 here. Only 4 of the professors who were not overweight had high blood pressure. So not overweight had high blood pressure. So you can see this one here is 4. Find the probability that a mathematics professor will not have high blood pressure if he is not overweight. If he is not overweight. So it is given that he is not overweight. This is what the question is asking for. Let's fill in the table first. So 100 minus 30, we get 70. 70 minus 4, 66. 30 minus 10, we get 20. And this one here is 86. 10 plus 4, we get 14. So using the formula, okay, referring to the table, you can see that the intercept between H complement and W complement is this. So 66 over 100. And then the probability for complement of W, we have 70 over 100. Substitute in the values. Simplify and you get 33 over 35. Page 16, independent and dependent. Independent events. A and B are independent events if probability of occurrence of event A has no effect on the probability of occurrence of event B and vice versa. For example, when we toss a coin twice, the result of the second toss will not be affected by the result of the first toss. Dependent events. A and B are dependent events if the probability of occurrence of one event influences the probability of occurrence of the other event. For example, two balls are drawn without replacement. The outcome of the second draw depends on the first ball because the condition is changed. Formula: if A and B are independent, then A intercept B equals the probability of A times the probability of B. Conditional events: the probability of A given B equals the probability of A. Additional rule: probability of A union B equals probability of A plus probability of B minus probability of A times probability of B. Example 19. Two events A and B are independent. Given probability of A equals 1/3, probability of A intercept B equals 1/6. Find the probability of B. So using the formula P, A intercept B equals PA times PB we have 1/6 equals 1/3 times PB. Then the probability of B is equal to 1/2. Question B, the probability of A intercept B is the formula PA plus PB minus PA intercept B. Substitute in the values, simplify, and you get 2/3. Question C, the probability of B given A this is equal to PB intercept A over PA, then 1/6 divide by 1/3, that is equal to 1/2. For question D, the probability of complement B intercept complement A, refer to the De Morgan rule in page 8. The probability of complement A intercept complement B equals to the complement of A union B. So let's write that here. Union A complement. Okay. So this one right here equals to 1 minus the probability of B union A or A union B. It's just the same. So 1 minus, what was it? 2/3. And you get 1/3. Example 20. Given that the sample space 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the sets A, B, C, and D are given by 3, 6, 8. This is A. 3, 5, 7. This is B, C, and this is D. Are A and B mutually exclusive? Let's take a look at set A and B. So you can see that 3 is the common element in A and B. So A intercept B is 3. since there is an since there is a common element for A and B, we can say that A and B are not mutually exclusive. Question B, are A and B independent? So let's take a look. P A intercept B equals 1/10 because we have 10 numbers, and then the element that is common between A and B is 3, so there is only one element, so 1/10, and then the probability of A times probability of B equals 3/10 times 3/10, you get 9/100. So we can say that since P A intercept B is not equal to P A times PB, then A and B are not independent events. Question C, are A and C independent? So if you look at the elements of A and C, you can see that there is no intersection between them. So the probability of A intercept C equals 0. And then PA times PC equals 3/10 times 3/10. So that is 9/100. Since the probability of A intercept C is not equal to the probability of A times the probability of C, then A and C are not independent events. Question D, find the probability of A given C. So this one here is 0/3/10. So the answer is 0. Example 21, page 18. A bag contains 8 balls, 5 yellow and 3 red. A ball is drawn at random without replacement. Another draw is drawn. What is the probability that both balls are red? So let's draw a tree diagram first. The tree diagram will be like this. And then the probability of picking a yellow ball in the first draw will be 5/8. And then for the red ball is 3/8. For the second draw, if we have picked a yellow ball previously, then we are left with 4 yellow balls and a total of 7 balls altogether. So for the red ball, the probability is going to be 3 over 7. If we have chosen a red ball previously, then the probability of picking a yellow ball for the second draw is going to be 5 over 7, and red ball will be 2 over 7. The question is asking for the probability of picking red ball twice. So we have to multiply along the branches. Then we have 3 over 8 times 2 over 7. Simplify and we get 3 over 28. For question B, the balls are not of the same color. So the question is asking for the probability of yellow, red, or the probability of picking a red one and then a yellow one. Let's use the same tree diagram. So yellow, then red, so this branch, or red and then yellow. So you have to multiply and add along the branches. 5 over 8 times 3 over 7 plus 3 over 8 times 5 over 7. Simplify and you get 15 over 28. A ball is drawn with replacement. Another ball is drawn. What is the probability that both balls are red? So for this part of the question, we need to draw another tree diagram. The probability of picking yellow ball for the first time is 5 over 8. And then this one here is 3 over 8. And then whatever ball you're going to pick, there will be a replacement. So the number of the ball will remain the same. So the probability of taking a yellow ball for the second draw is also 5 over 8. So 3 over 8 here, 5 over 8, 3 over 8. Question is asking for PRR. Again, you're gonna multiply along the branches. 3 over 8 times 3 over 8. Simplify and you have 9 over 64. The probability that the balls are not of the same color, PRY plus PYR. Plus means or. So YR or RY. Then we have 5 over 8 times 3 over 8 plus 3 over 8 times 5 over 8. Simplify and you get 15 over 32. 19, example 22. There are 60 students in a certain college. 27 of them are taking mathematics, 20 are taking biology, and 22 are taking neither maths nor biology. So I'm going to draw a table for this question. M is for the students who are taking math, and B is for biology. We have total of 60 students. out of this 60 students, we have 27 who are taking math, and then 20 are taking biology, 22 are taking neither math nor biology, 22 are taking neither math nor biology, 22. Let's fill in the empty spaces. So 60 minus 20, we have 40 here. 40 minus 22, we have 18. Then 27 minus 18, we have 9. 20 minus 9, we have 11. 11 plus 22, we have 33. So find the probability that a randomly selected student takes both math and biology. Math and biology. That is PM intercept B equals 9 over 60. Simplify that, you'll get 3 over 20. Then the second question is the probability of students who take math only. Okay, so taking math without taking biology. So this one, 18 over 60. Simplify and we get 3 over 10. A student is selected at random. Determine whether the event taking mathematics is statistically independent of the event taking biology. The probability of M times the probability of B equal to the probability of M intercept B. So PM times PB equals, PM is 27 over 60, then PB is 20 over 60. 27 over 60 times 20 over 60. Simplify that and you get 3 over 20. We have already calculated PM intercept B and we get 3 over 20. So we can make a conclusion here, since PM times PB equals PM intercept B, then the events taking mathematics and taking biology are independent. Example 23. The probability that Bob is late for college on any day is 0.15 and is independent of whether he was late on the previous day. Find the probability he is late on Monday and Tuesday, and then the probability that he arrives on time on one of these days. So let's draw a tree diagram. Okay, so L is for late. The complement of L is on time. The probability of Bob getting late is 0.15. So on time will be 0.85. Then for the second day, the probability is independent of the previous day. So it will be 0.15 still. Then 0.15, 0.85. Right. For question A, late on Monday and Tuesday. So probability of L refer to this branch, 0.15 times 0.15, that gives you 0.0225. B arrives on time on one of these days. So P, L, complement of L, or P, complement of L, and then L. Or means plus to refer to these branches, L, and then complement of L, and then L. So 0.15 times 0.85 plus 0.85 times 0.15. That gives us 0.255.